Welcome back. Today we're going to be talking about digital film transfers again, or DTF. We are going to talk about how to take this image you see here, this AI generated lion, and look like it was traditionally screen printed as a white design on black garments. And what that means is we're not going to let all those shades of gray that you see there print as gray. Everything that we're going to be doing is going to print out as white ink, so it looks as close to screen printing as possible. Now, why would we do this? Well, for some of us, we like a challenge and we like to push the limits of what we can do. I like to be geeky about this sort of stuff. The other reason is it's very common for us, at least on the screen printing side of things, where we need to fill in for our customers garments that may have gone missing. Basically, they just need extra garments. But if it's a design like this, where it's a larger design, this one's 12 by 18, is a screen printed white halftone, they may not have the bandwidth to set up and print that again. So how do we fulfill that orders? Well, in order to make it look the same, let's go through, break this down on all those little things that you want to look out for, and then print this out on our DTF printer downstairs and see how good we actually did. All right, so the first thing I want to point out is that this is a design that we have printed in the past. I did this for my classes, and you can see here the color separations that I did for that. Very simple, 2-screen, white base, white highlight. That's what the white base looks like by itself, and this is what my white highlight looked like. This is in comparison to the image, very similar. Now, what we need to do if we are to approach this to reproduce the results of screen printing is if you've got those separations already done, take those separations and halftone them. When you are going through color separations from an image like this into printable images like this, you're working with compensation for dot gain, both physical dot gain and optical dot gain. There's been a lot of videos on that in the past that we've done, a lot of stuff that I've talked about. It's all part of our Photoshop package. But basically what you're doing is, I'm just going to show you the effects of it. I'm going to turn this off, select this. I'm going to invert it. And this is showcasing best as Photoshop can what the white base looks like if you were to take the negative space and take a look at it. That's what the inversion does. So if we compare that to the RGB image, the grayscale version, you're like, whoa, what happened there? That disappeared. But if I invert it back and turn on the black background, you see the effect of dot gain and some of the optical dot gain that we have going on here. So if I was to grab my eyedropper tool, make sure, 3x3 average, and use my info window to see the percentage, that halftone dot size, we can see that we're dealing with some pretty small stuff. 3, 4, 5, some 2%, 1%, 2%. Up in here, I have 1% dot. Now in screen printing, we know that we don't really keep those 2 and 1% dots very well unless you're really dialed in. When it comes to digital film printing, actually printing out on your DTF printer, you have that picoliter droplet size. And it's going to be able to spit out white ink and recreate, in essence, whatever you have here. So we need to be very aware of, again, that optical dot gain and that physical dot gain. Is that dot that it printed out going to grow a little bit? Because we have layers that we're dealing with when we're creating our transfer. We have the carrier that's on the PET film. So that little layer that holds onto the ink and that releases from the film. Then you have the white that you're printing, and then however thick or thin that white is, and then your adhesive backing. So all of that, when you look at your transfers, has a bit of volume. So that then goes on the shirt. It gets smashed with the heat press, and so you can get a little bit of spread. We also have some other things that we'll look at when we actually do the transfer. So this is all preamble to, we're not simply taking this, pulling the black out of it and hitting print, because the amount of white that we would create that way is way too much. I actually have some examples of that already printed in which You know, it looks fine by itself, but it is way brighter than my image here. What we're going to do here is we're going to show you how to quickly compensate for some of that dot gain if you haven't already done color separations for it. We're also going to show the color separation that I did and take that information, convert to halftone, and then show you what that looks like and give you some really good compare and contrast visuals. So what we're going to do is we're going to take the color separation that I did, the white base, convert that to halftone. We're going to do a couple versions, 35 line, 55 line, so that you can see as best we can preview what all of that's going to end up looking like. So let's quickly go over how we want to make adjustments for dot gain and why we're making adjustments by duplicating one of these RGB portions of the design. If we were in grayscale, then we can grab the grayscale image and duplicate that. But because the image is grayscale in RGB, I can take one of these and duplicate it, and I can work with that. So whenever you do that, you always want to double click, convert to a spot color, make white. We're going to leave this coverage at 100. Going to invert it so I can see it on the background. And you can see right away the difference between doing this and this on the background is this is the results of dot gain or compensating for dot gain. And this is what that raw image looks like. I'm going to pull up my curve window. I'm going to take this point, my 75, make that 90. And now all of a sudden you can see how the image starts to look good. But what I've done here is I've taken, try and get in here, that 25% dot, whoop, it's up there at about a 5. Actually, it's more to a 4 in that curve, but I like to make that, if I'm doing screen printing, I'd make that about a 5. But this is just to show that that 25% dot became a 4% dot. That's how much compensation we are making so that when that 4% dot hits fabric, it creates a little bit of a physical spread, that physical dot gain, and then also that optical dot gain for how bright that white dot looks on the fabric for versus contrast. So it looks like shadows. So that's the foundation that you are going to be working with to create a good looking transfer. So I'm going to click cancel on this because I already have this done. Actually, you know what? I'm going to click OK just as a way to compare. So that white base, this white base, a little bit brighter because I changed the source image just a little bit. These, to give you a deeper answer, these source images that I did here, we brightened them up for our class, and the original image that we were working with was a little bit duller. So hence the slight change in what you're seeing there on screen. So there's the white base that I was working with. There's my current quick adjustment. And you can see here with the halftones, we're very similar, 6, 5, 4, 3, 4. Up in here, do I have that? Still, it's very, very similar, just my source image changed a little bit. Yay for being consistent, right? I'm going to go ahead and remove that. And I'm going to work with that white base that we already did for our color separations that we printed. Because remember, the reason for our video is to showcase a way to take that screen printed image that you did, convert it to halftones, and do this as a DTF image, so that it looks closer to that screen printed version. And you know what? It may very well be that this is something you choose to do in the future for a lot of projects like this. It's like if they want a white on black, well, now you know how to convert that so it looks like screen printing. Let's go through these steps. I'm going to, just like all the other videos you see about converting to halftone, I'm going to duplicate this into a new channel, and here we go, the white base. Now it doesn't matter what this is. You know, this is, what is it? What's the mode? Multi-channel. It's been a while since I've used multi-channel. Doesn't matter what that is. Now I can take this and invert it if I want, or leave it this way. The results are basically going to be the same. So I'm going to leave it like this. I'm going to go up under image, mode, bitmap. 300 DPI because that's the size of the resolution of the file that you send into your DTF printer. Going to click OK. It's going to pull up that halftone screen that I selected. And we're going to choose 35 line for this. Now, historically, you're seeing 35 line be chosen for a lot of these prints because usually they're not white ink being printed and just white ink. It's a full color design. So you need to be able to print your color down and then get your white ink to fall on top of that, centered in that dot. Now, a lot of DTF printers have problems with really tight registration, something that, again, we as screen printers deal with all the time. So you have to manually adjust how your white ink falls, where it falls, so that it's pixel perfect. And even then, a lot of DTF machines have troubles with this for a number of mechanical reasons. So eliminating that color being printed means that we can do different things with our dot halftone size, how small or fine our detail is, because we don't have to worry about the registration of the white. We're printing light. So I'm going to do this one at 35, then I'll do another one at 45, and then a final one at 55. And I'll print all of those out. I'll transfer them to a shirt, and we'll see how they all look. So I'm going to click OK here. I have this is a bitmap. I need to go up under Image, Mode, Grayscale in order to be able to use the file. I'm going to select all, I'm going to copy. I'm going to do this into layers. So I'm going to go New Layer, click OK. I'm going to move this up here, Control V, turn that off so I can actually see what's going on. Now I need to select all the white here. I'm going to grab my magic wand tool, make sure contiguous off. Just make sure that I am clicking on a white area, delete, Control D. Now, because we have black left over, because that's what we half-toned, double click this, and I'm going to do a color overlay of white. And that's what we got. This is the grayscale info of my white base converted to a halftone dot here in Photoshop. And this is the quality of that halftone dot. Now, Photoshop is not perfect. Photoshop is not RIP software. So you know what? I was right. Photoshop is not RIP software. I continued on with the exercise. I did 35, 45, and 55 at a 300 DPI halftone conversion. And the artifacting just got worse. I did print them out. They look terrible. Even on a really good shirt, they just look terrible because those halftone dots just couldn't hold up to it. And this is what they ended up looking like. This is the 55 line. The artifacting in here is not good at all. There's 45 and there's 35. It just doesn't look good at all. So what I did was I went back to the drawing board and I said, okay, well, I know higher resolution is something that solves these artifact issues because it's the resolution that, you know, Photoshop just can't create a good halftone representation. So I created this file over here, just a simple changing of the resolution. I went up under image size, made sure it was 600 DPI. File size definitely went up in resolution, but today's computers can handle that no problem. So I did the same thing that I did before. I duplicated that white base, converted it. We'll go through this really quick. Duplicate channel into new. Okay. And I'm going to go image mode, bitmap, 600, 600, click OK. 55 line, because that's the goal resolution. That's a goal lines per inch in order to reproduce the screen printed design as a DTF transfer. 22.5 angle around, we're going to click OK. Now I don't need to convert here. I'm just going to click select all. I'm going to click copy. I'm going to go back to the original image and go here. Make sure that is off. Just paste. And now I have that 600 DPI bitmap file, the halftone conversion here. So I just need to use my magic wand. Contiguous is off. Click the white space and then hit delete. We're still going to have that black on black effect. double click this color overlay in white, and there we go. So what we have here, we are at 50%, there's 100%. You're always going to have some resolution issue, interference. The best I can do is go at 100 here and then show you 55 here, give you that same resolution. Well, it can't go at 100 and 100. What we can do for resolution, you can see these, it looks like a dice with rolled a bunch of fives versus 600 DPI gives us much better resolution. Now, as I zoom in and out, we have that interference pattern. So I'm going to duplicate that, click OK, double click, spot color, OK, invert. Just need to select it, invert it, look at it on a black background, infinitely better. So how do we progress from here? Well, we go back here, we turn this off, and we just save a 600 DPI PNG file. File, export, export as. So smaller file, transparent PNG, 3.6 meg file. Because it's only white, it's not going to have a big amount of memory taken up to it. Large file, see you in the lives. So here is that visual history of what I went through during this video to try and get a good reproduction from a screen printer's point of view, a faithful reproduction of a screen printed design as DTF. This image here is my first original attempt to just do the traditional way for DTF and knocking out the black. The image itself is fine, but it's not what we did for screen printing. And the purpose of this is to recreate what was done in screen printing. So it looks like it was screen printed. So that was test one. This is one of the attempts for doing that 300 DPI halftone conversion. It didn't transfer as well as I wanted it to. I learned a few things in this with the amount of ink that's going down on the transfer sheet, and then the amount of adhesive that ends up adhering not only to the ink, but to the little bits in between, because we have so much ink going past into very tiny areas. We also have a little bit of humidity, moisture being created underneath that print head. So the film, the better the film you got, the more moisture it can absorb. Ended up grabbing a little bit, so I had a lot of glue there as well. So that was another learning curve that I had. But the results of the Photoshop halftone conversion at 300 DPI, they just look terrible. All that pattern that we saw is evident right here. Now this is the worst example. I have another one right here that definitely looks better, but we still have all this unsightly pattern going on here. So let's take a look at the screen printed design right next to the 600 DPI, 55 LPI transfer that we just did. Now, I apologize for this in advance. I forgot I resized my design for my class because we were manually screen printing this. So I made it a little bit more manageable for manually printing. But this is screen print, 55 LPI, very soft, very flexible. I did lose some of my 1% dots and struggled keeping all of my 2% dots, which again is very normal in what we're doing. Here is the result of my 600 DPI halftone conversion, and it is very similar to what I got screen printing. In fact, side by side, other than a couple of small dots that did not transfer very well, again, we're transferring very, very small pieces of ink onto fabric. They ended up looking almost identical, and that was my goal. When I'm touching both of these side by side, there isn't a whole lot of difference because the solid areas are so small, and there is, because it's almost all dots, everything is a hinge. It just flows and drapes really well. Would I do this again? I'd only do this on small scale. What I learned from this is, again, as that print head travels over the film, it creates a little bit of an atmosphere on the film. So because they have dots so close to each other, when that powder hits it and then melts, stuff is so close together that it can end up becoming a little bit of a solid sheet in some of those areas with that adhesive. And multiple presses, even with textured fabrics, don't quite push that hot melt powder into the shirt. But I would definitely do it again for a smaller print run. A challenge to get it all to transfer correctly. Now, before somebody says, go do a wash test, those small dots don't hang on there. You are absolutely partially correct. The durability of your print in the wash is 100% related to both your adhesive, the temperature and the time, and the fabric mass of your garment. These are ring spun garments from Allmade. They have a fantastic surface for printing on. There's more surface, there's more fabric mass there for those little bits of ink to hang on to, just like with screen printing. But if you go onto a lighter weight shirt, something that's more of a promo weight, this won't fly. You can't do it. It's not gonna hold all those little dots that you want. But if you're going onto a higher fabric mass shirt, a really nice ring spun, it will hold. And I've done the wash testing, currently up to about 5 wash tests, and I'm not seeing anything drop out yet. Thanks for taking this journey with me. I learned a lot doing this. DTF versus screen printing, that was a fun and frustrating struggle. Thank you so much for watching and staying with me through this process. If you liked what you saw here, hit that little like and subscribe button. Leave a comment down below. You know, if you have a buddy who is looking to get into digital film transfers, send them this video. This is education at its gnarliest. You know, getting in there and learning why, what, and how. Thank you all very much. See you guys in the next one.